In this video, we're going to look to evaluate this definite integral with partial fraction decomposition, which basically means we're going to split this into two fractions to make it easier to solve. So our goal is to split this into something that looks like the following: a over x minus 1 plus b over x plus 2 dx. So our goal is going to be to find a and b, and if you can imagine the fractions being added back together, we would find a common denominator to get this result. So what we're doing is we're reversing that by pulling the fraction apart. Now the way we solve for this is we think about going in the opposite direction. So I'll write it out in this example. So we have a over x minus 1 plus b over x plus 2. Now if we wanted to simplify this fraction, we would find a common denominator, which would be x minus 1 times x plus 2. So we multiply both sides by, we would multiply the left-hand term by x plus 2 over x plus 2, and we multiply the right-hand term by x minus 1 over x minus 1. So this will give us the common denominator if we were going that direction. If we were to write this out, we get a times x plus 2 plus b times x minus 1 all over x minus 1 over x plus 2. And this would be equal to our original, 9 over x minus 1 times x plus 2. Now, because the denominator is the same, we really only focus on the numerator. So a lot of times when you see examples that I do, I only focus on the numerator because that's all that I need. So I'm going to focus on the equation a times x plus 2 plus b times x minus 1 equals 9. And I'm going to show you a shortcut for solving this, but really we just have a system of equations that you'll see in other examples. So what we'll do for this one is we're going to zero out one of the terms and solve for the other. So for example, I'm going to let x equal 1. Well, what happens then is I get a times 1 plus 2 plus b times 1 minus 1. Well, that gives me 3 times a. B, this actually just becomes 0. So plus 0, and then equals 9, which gives me that, dividing both sides by 3, that a equals 3. Very similarly, I can zero out the a. Now this method will not always work, but it works great for this one. In other videos, I'll show you other methods for solving the system. So in this case, we would have negative 2 plus 2, so that zeroes out the a for us, plus b times negative 2 minus 1. So that zeroes that out, and we get negative 3 times b equals 9, which gives us b equals negative 3 when we divide both sides by negative 3. So now, we put these back into our integral. We have 3 over x minus 1 minus 3 over x plus 2. If you want, you could keep the negative up here. That's kind of user preference. This is basically two separate integrals. We have 3 over x minus 1 dx minus 3 over, the integral of, over x plus 2 dx. These are both going to be natural logs. So what we're going to have is 3 times the natural log of the absolute value of x minus 1 minus 3 times the absolute value, minus natural log, of the absolute value of x plus 2. This is an indefinite integral, and so we end with a plus c. At this point, if we wanted to do some properties of logs, we could. You can see they're both multiplied by 3, so if I factored out the 3, ln of absolute value of x minus 1 minus ln, absolute value of x plus 2. I'm going to just leave the plus c alone. Now, when we subtract 2 logs, that's division. So this can be written as 3 natural log of the absolute value of x minus 1 over x plus 2 plus c. You can also put the 3 up in the exponent. But this is enough for now, just for me to show you that because we have logs, we could do some simplification. This answer here was the final correct answer, so this would be perfect as well.